Hi guys. So on Monday and Tuesday you were practicing the compound formula. So if you remember the regular compound formula that we did Monday and Tuesday was A equals P times 1 plus R divided by N to the NT power. This formula is when we saw compounded quarterly, compounded monthly, compounded daily. There's another second compound formula. This one specifically, though, is when we do what we call compound continuously. When this special word continuously is in the problem, we're going to use this new formula here. A equals P times E to the RT power. A is still your final amount. P is still your initial amount. R is the rate, and we still convert the percent to a decimal by dividing by 100. And T is time. The only special thing we have here is we have this new E. E is a special number in math, similar to pi. We know that pi is 3.14. Well, E is its own special number. It's approximately 2.718. Just like pi, it goes on forever and ever. It's an irrational number. It continues forever. E is the same way. What's nice, though, is it is a button on the calculator that we're going to be using. So before we get started, I'll show you where the E is. So E, if you hit the blue second button, and then third button up on the left, it says LN. You should get that E with a spot to type in an exponent. We're going to be using exponents with E. There is another spot for it, but we are going to be using the exponents with E, so we're going to stick with this one. So again, that was second ln. And again, you can get this same app that I have right here of the calculator. I have it on Google Classroom under the section Distance Learning. There are instructions for downloading it, so feel free to download if you don't have yours at home. So this is going to be our new formula. So if we take a look, number 1 here, it says a person invests $350 in a bank account that promises a yearly rate of 2% continuously compounded. So again, when you see that word continuously, this is going to be the special keyword that tells us we are using this new formula. Part A says write an equation for the amount this investment would be worth after T years. So the person is investing $350, so that is their initial amount, which is P. And we have a rate of 2%. So R is 2%, but just like we normally do, we need to divide by 100 to move the decimal place over twice. So the R we are going to use is 0.02. So write an equation. We are going to fill in the information. A equals P is 350. E, remember, is a number, so we're going to use it just like we're using that 350 right now. We're going to use E. And then its exponent is going to be 0.02 t. Part B now says how much would the investment be worth after 20 years? This is our t value. We are going to make t 20. So we are going to plug in the 20 for t. You're going to type this straight into your calculator. So we have 350 times E. Again, that's the second blue button. And then ln, that's the third button up on the bottom left. There's your E with the exponent. 0.02 times 20. Hit enter. And just like what we've been doing, it does not tell us where to round, but we are talking about money, which means 2 decimal places. So $522, and we're going to round to 0.14. The 8 tells us to go up. So there's your final answer. So question 2. A person invests $5,000 in an account that earns 3.5% annual interest compounded continuously. How much money will the person have after 3 years? So again, if that word continuously is there, I know the word compound is there just like the other day, but this time we have the even more special word continuously, which tells us we're using this new formula. We are investing $5,000, so that is our P, our initial amount. The rate, R, is 3.5%. We're going to divide by 100 and make it 0.035. And we want the money after 3 years. So T is 3. So we are going to plug this information into the formula. Again, E is a number just like the rest of these numbers that we're using. So we are going to plug this straight into our calculator right now. So we have 5,000. E, again, that was second, the blue button. ln, third button up on the left. Our rate, 0.035 times 3. And again, it's not telling us where to round, so 2 decimal places, $5,553.55. Final answer. Okay, let's try the next one, number 3. A person wants to invest money in an account for 8 years that earns 6.5% annual interest compounded continuously. How much money should the person invest if they want their investment to reach $9,000? So here's that word continuously again. So there's our formula. We want to invest money in the account for 8 years, so that 8 is our time, T. We have 6.5%, so that is our R. And again, divide by 100, so we have 0.065. Now this time we want to know how much should we invest, because we want to reach $9,000. So the 9,000 is our final amount this time, the A. So we've done these with all the other problems. So it's going to be similar. Filling in the information I have. P is multiplying with this E with its exponent. So the E with the exponent, you are going to plug into your calculator. So we have 9,000 equals P times, plugging into our calculator, the E, second ln, to the exponent, 0.065 times 8. You're going to get a long decimal like we've done with all the others. You're going to use the entire decimal because, again, we won't round until the end. So use the whole decimal, 1.6820 0.2765. Again, the p is multiplying with this number, so to get p by itself, we are going to divide this number to the other side. So we're going to have p equals, we're going to take 9,000, divide it by this entire decimal. And again, the problem does not tell us where to round, so 2 decimal places for money. So $5,350. And 0.684, the 4 says just stay where you are, so we're going to stick with the 0.68. So there is your final answer for number 3. All right, last question. It says Gabriel invested $3,400 in an account paying an interest rate of 3.25% compounded monthly. Camilla invested $3,400 in an account paying an interest rate of 3.5% compounded continuously. After 11 years, how much more money would Camilla have in her account than Gabriel to the nearest dollar? All right, so now we have 2 different situations going on here. We have Gabriel and we have Camilla. Now, the thing you have to be careful with, Gabriel is compounded monthly. Camilla is compounded continuously. So these are our 2 different types of compounding. Each one is its own formula. Continuously for Camilla, this is the formula that we're using right now. The A equals P times E to the RT. Whereas Gabriel, compounded monthly, Gabriel is going back to the formula from Monday and Tuesday. So compounding continuously is this formula with the E in it, PERT it looks like. Whereas any other compounding that is not continuously will go back to the formula like Gabriel with the N's in it. So we'll do Gabriel. He's investing $3,400, so that is his P. His rate is 3.25%. Divide by 100, we get 0.0325. And it's after 11 years, so T is 11. Now, he does have that extra variable, the N. It says compounded monthly. So if we're talking about years in 1 year, how many months would we hit? If you remember Monday's lesson, we did have that little section that listed out all the different things that you would use for N based on what word was there. Monthly would be 12. So I'm going to plug in these numbers for Gabriel. And then from there, we can type that straight into our calculator. So 3,400 times 1 plus 0.0325, I think it was, divided by 12 to the power 12 times 11. Hit enter. Keep the entire decimal right now. We're not done with the problem. We're not going to round. 0.803379. Okay, Camila, she is investing $3,400. So her P is also 3,400. She has a rate, though, of 3.5%. So divide by 100, we have 0.035. And she is looking at 11 years also. So T is 11. So plugging in. Oops. You don't have to fill in anything for E because remember, E is a number just like the rest of these. So once you fill in those numbers, you can plug it straight into your calculator like we did for Gabriel. So 3,400 times E second ln, 0.035 times 11. So there's Camila, 4,906.688693. So there's their amounts. And now to answer the actual question, how much more money would Camila have than Gabriel? We want to subtract the two. So subtracting. We can do that right on the calculator. Now you can round to the nearest dollar. If you rounded before this, you could still luck out and get the right answer. However, there will be some times where you could be off by a couple dollars. So this is why you want to make sure that you wait until the very end of the problem when you're done with everything you need to do, and then you round. So it's said to the nearest dollar, so 0.8 rounds up to $138. So that's your final answer. So there's the lesson. Let me know if you have any questions. Like always, please ask me questions on Google Classroom. Send me an email. I'd be more than happy to help. We can touch base and figure out how we want to go about it. So please reach out. Let me know what I can do for you.